Stars do not actually twinkle. The twinkling happens in the 60 miles of atmosphere between the star and your eye, and planets are too close to twinkle at all. On a clear night, look up at the sky and you will see stars twinkling. They appear to flicker, brighten, dim, and shift colors. It is one of the most recognizable phenomena in the night sky. Poets have written about it for thousands of years. But here's the truth. Stars do not actually twinkle. A star in space shines with perfectly steady light. The twinkling happens entirely inside Earth's atmosphere. And if you know where to look, there is an easy trick to see something that does not twinkle at all. The scientific term for twinkling is stellar scintillation. It is caused by turbulence in Earth's atmosphere. When starlight enters the atmosphere, it has to pass through about 60 miles of air before reaching your eye. That air is not uniform. It contains pockets of different temperatures, densities, and humidity. Each pocket refracts light at a slightly different angle, acting like a tiny lens. The starlight gets bent, scattered, and redirected as it passes through. What was a perfectly straight beam in space becomes a jittery, shifting stream of light by the time it reaches your pupil. The result is the flickering effect we call twinkling. Here is the fascinating part. Planets do not twinkle. If you look carefully on a clear night, you can actually tell stars and planets apart with your naked eye just by watching them. Stars flicker. Planets shine with a steady, unwavering light. The reason comes down to angular size. Stars are so far away that they appear as single points of light. A point of light is easy for atmospheric turbulence to distort. But planets, even though they look like dots, are actually tiny disks when viewed from Earth. Each part of the disk is slightly distorted by the atmosphere, but when you average all those distortions across the disk, they cancel each other out. The result is a steady light that does not scintillate. Several factors make twinkling worse. Stars closer to the horizon twinkle more dramatically because their light has to travel through more atmosphere. A star directly overhead passes through about 60 miles of air. A star near the horizon can pass through 400 miles or more. That is why sunsets are red and stars near the horizon sometimes flash red, blue, and white. Different colors bend at different angles. Turbulent weather also increases twinkling. Hot rising air, jet stream activity, and temperature gradients all amplify the effect. Astronomers use atmospheric turbulence measurements to rank observation sites. Mauna Kea in Hawaii and the Atacama Desert in Chile have some of the calmest atmospheres on Earth. This is exactly why major telescopes are built on mountaintops and why space telescopes exist at all. The Hubble Space Telescope operates above the entire atmosphere, so its view of the stars is perfectly sharp. Hubble sees stars as steady, unblinking points. From space, the night sky does not twinkle. Ground-based telescopes use a technology called adaptive optics to cancel out atmospheric distortion. Hundreds of tiny mirrors flex and adjust in real time to counter the turbulence, effectively canceling the twinkling. Twinkling is beautiful to look at, but for astronomers, it is noise. And getting rid of it was one of the biggest challenges in modern astronomy. If you found this fascinating, subscribe to Curious Science. New science explainers every week.